You know, when people hear the speed of light, they think it's just a big number you memorize and move on from. But that never sat right with me, so I kept poking at it like a curious kid taking apart a radio to see why the music comes out. After a decade of studying light speed, what slowly revealed itself was not merely a limit on how fast things travel, but a kind of structural rule that shapes reality from the inside. Light does not just move through space and time, it defines them. The geometry of the universe quietly arranges itself around the paths light can and cannot take. If you draw those paths, those cones that mark what can influence what, you find that causality itself is sketched in beams that never slow, never hurry, and never negotiate. Everything else must compromise. This constancy is deeply strange. Motion is usually relative. Walk on a train, and your speed depends on who's watching. But light refuses to play along. No matter how you chase it, it always slips away at the same rate. This stubbornness forces space to shrink and time to stretch, not as philosophical metaphors, but as precise adjustments that keep the cosmic bookkeeping consistent. Lengths contract, clocks disagree, and yet the universe remains mathematically self-consistent, as if it values elegance over comfort. What surprised me most is how this simple rule echoes into the largest and smallest scales. At the smallest, quantum processes flirt with light speed in subtle ways, weaving probabilities along light-like paths. At the largest, the history of the universe can be compressed into patterns where infinity becomes manageable, where the infinite future and the infinite past can be compared without contradiction. Light acts as the thread stitching these extremes together, hinting that the universe is not a random pile of facts, but a tightly constrained logical structure. There is also a humbling lesson here. Because information cannot outrun light, the universe enforces a kind of cosmic modesty. No observer ever has the whole story at once. Horizons form around black holes, around the observable universe itself, and beyond them, perfectly real events unfold forever, inaccessible to us. Reality, then, is not just what exists, but what can, even in principle, be known. After 10 years, I no longer see light speed as a barrier to ambition, but as a guide. It tells us which questions are meaningful, which explanations can fit together, and why the universe has the shape it does. It is less like a speed limit sign and more like the grain in wood, quietly determining how the whole structure can be carved. And the funny thing is, after all that work, the biggest lesson I learned is that light isn't trying to be mysterious at all. It's just doing its job perfectly and daring us to be clever enough to notice why that has to be so. When we say the speed of light, it's tempting to picture a very fast thing moving through space, like a cosmic bullet that just happens to win every race. But that picture misses the point almost entirely. Light speed is not remarkable because it is fast. It is remarkable because it sits at the foundation of how reality is allowed to behave. It is woven into the rules before anything else gets a chance to move. If you removed light from the universe but kept its speed as a principle, the structure of the world would still be there, quietly enforcing what can happen and what cannot. What makes light speed fundamental is that it does not describe light alone. It describes the maximum rate at which cause can lead to effect. It is the universe's way of saying that influence is not free to roam wherever it wants. Every interaction, every signal, every physical consequence must respect this limit. Even forces that do not involve light directly still obey the same constraint, as if the universe is following a master tempo that nothing is allowed to rush ahead of. Light just happens to move at that tempo because it has no mass to slow it down. This changes how we think about speed itself. Normally, speed depends on context. A car can be fast on a city street and slow on a racetrack. But light speed does not depend on context. No matter how you move, no matter how you try to measure it, it remains the same. That stubborn consistency forces the universe to adapt around it. Space adjusts, time adjusts, and our everyday intuitions are the ones that end up being negotiable. The limit stays put while everything else bends. Seen this way, light speed is less like a performance record and more like a conversion factor between space and time. It tells you how much distance counts as how much duration. Change that value and the entire geometry of reality would reorganize itself. The shapes of orbits, the lifetimes of particles, the way stars burn, and the way the universe expands would all be different. The number is not arbitrary. It is tuned into the logic of the cosmos. It acts as a glue holding space and time together as two aspects of a single structure rather than separate stages where events merely happen. There is also something deeply democratic about this limit. No object, no observer, no clever machine gets a special exemption. The same rule applies everywhere and always. This universality hints that light speed is not a property of things in the universe, but a property of the universe itself. It is written into the background, like the rules of a game that even the most powerful players must obey. In that sense, studying light speed is not about chasing photons, but about reading the fine print of existence. Perhaps the most striking implication is philosophical. If light speed is fundamental, then reality is not infinitely connected. There are delays, separations, and horizons that are not due to technological weakness, but to the nature of the universe. Events can be real and yet forever out of reach. Knowledge is constrained not by curiosity or intelligence, but by the architecture of space-time itself. The universe allows understanding, but only within carefully drawn boundaries. So after staring at this idea long enough, you stop thinking of light speed as an impressive number and start seeing it as a quiet lawgiver. It does not shout. It does not change. It simply sits there, shaping everything that happens, reminding us that the deepest rules of reality are often the ones that seem the most ordinary at first glance. To say that light defines the structure of space and time sounds poetic at first, but it is actually a very literal statement about how the universe is put together. Space and time are not passive containers where events politely line up. They are shaped, measured, and even brought into relationship with each other by the way light moves. If light behaved differently, space and time would not merely look different to us, they would be different. Consider how we decide whether two events are simultaneous. You might think that simultaneity is obvious, something the universe hands to us for free. But the moment you take light seriously, simultaneity becomes slippery. To decide whether two distant events happened at the same time, you must exchange light signals. And because light takes time to travel, the answer depends on motion. Two observers moving differently will disagree, not because one is mistaken, but because space and time themselves refuse to settle on a single universal clock. Light forces that disagreement, and space-time rearranges itself to accommodate it. This is where space and time stop being separate ideas and merge into a single structure. Light acts as the ruler and the stopwatch simultaneously. Its speed sets the conversion rate between distance and duration. Without that fixed speed, there would be no consistent way to compare meters to seconds across the universe. With it, space-time gains a geometry, one that is not Euclidean, not intuitive, but rigidly constrained. Straight lines become world lines. Distances become intervals, and the shortest path between events depends on how light could travel between them. The most revealing feature of this structure is the light cone. From any event, light spreads outward, marking what can be influenced and what cannot. Inside the cone lies the possible future. Outside it lies the forever unreachable. This is not a technological limitation, but a geometric one. Space and time are carved up by light into regions of causality and separation. You do not need equations to feel the weight of this idea. It means the universe has a built-in notion of order, a way of preventing paradoxes by forbidding certain connections altogether. What is striking is how natural this feels once accepted, and how alien it is beforehand. We are used to thinking that space exists first, time ticks along second, and light just happens to move through both. In reality, the order is reversed. Light's behavior dictates how space stretches and how time flows. When speeds approach that of light, clocks slow down and lengths contract, not as illusions, but as structural adjustments. Space-time flexes to protect the constancy of light, like a framework that bends rather than breaks. This becomes even more profound when gravity enters the picture. Gravity is not simply a force pulling objects together. It is a reshaping of space-time itself. Light follows the curves of this geometry, bending around massive objects, tracing the contours of warped space and slowed time. By watching how light moves, we learn how space-time is shaped. In that sense, light is both the sculptor and the probe. defining the structure and revealing it at the same time. There is a quiet elegance in this arrangement. The universe does not need extra rules to keep things consistent. One principle, the fixed speed of light, ripples outward and organizes everything else. From atomic processes to cosmic evolution, space and time obey the same underlying logic. They are not arbitrary stages, but dynamic participants, constrained and informed by the paths light is allowed to take. Once you see space and time this way, they lose their absolute status. They become relational, flexible, and deeply interconnected. And light, doing nothing more than moving as it must, becomes the silent architect of the arena in which all of physics plays out. The idea that causality follows the paths of light sounds abstract, but it is really a statement about how the universe keeps its stories from getting tangled. Causes must come before effects, not because of philosophical preference, but because light draws the lines that connect events. If an influence cannot travel along a path light could take, then that influence simply cannot happen. The universe enforces order by geometry rather than by rules written in words. Imagine any event, no matter how small, a particle decaying, a star exploding, a thought forming in a brain. From that event, light spreads outward in all directions. Those expanding paths mark the only regions where consequences can appear. Anything outside that reach is not just distant, it is causally disconnected. No signal, no force, no information can jump across that gap. In this way, light does not merely illuminate events after they happen, it defines where their effects are allowed to exist at all. This reshapes our intuition about time. We often think of time as a universal river, carrying everything forward together. But when causality is tied to light, time becomes local. D. Different observers carve the universe into now, past, and future in different ways, yet causality remains intact because light-like connections never change their order. Events connected by light or slower than light signals always agree on which came first. The universe tolerates disagreement about simultaneity, but never about cause and effect. What is remarkable is how robust this structure is. Even when space-time is curved, twisted, or stretched by gravity, the causal order survives. Light bends, cones tilt, horizons form, but the rule remains the same. Causes must lie within the past light cone of their effects. This is how the universe avoids contradictions without supervision. There is no cosmic referee checking timelines. The geometry itself does the policing. This also explains why some things feel frustratingly impossible. You cannot send a warning back to prevent a disaster you just observed far away, because the information about the disaster arrived on light that took time to reach you. By the time you know, the causal window has closed. This is not cruelty built into nature, it is consistency. If the universe allowed causal shortcuts, it would permit loops, paradoxes, and logical breakdowns. Light speed acts as a safeguard against that chaos. Causality tied to light also gives meaning to the concept of an event horizon. Around black holes, light cones tip inward so severely that all future-directed paths point toward the center. Once crossed, no signal can escape, not because space is blocked, but because all causal routes lead deeper in. The future still exists beyond the horizon, but it is causally sealed off from the rest of the universe. Events that air are real, yet forever disconnected from us. Reality, then, is larger than what causality allows us to witness. On a more everyday level, this principle quietly governs all communication. Conversations, measurements, memories, everything depends on light or slower carriers of information. The present you experience is already a carefully filtered slice of the past, assembled from signals that arrive just in time to matter. Even your sense of now is stitched together from countless causal threads, each respecting the same universal speed limit. What makes this so elegant is its simplicity. There is no need to separately define cause, effect, or temporal order. Once you specify how light moves, causality falls into place automatically. The universe does not ask whether something should be allowed. It checks whether a light-like or time-like path exists. If it does, the event may influence another. If not, the connection is forbidden without exception or appeal. Seen this way, causality is not an abstract principle imposed on physics. It is a natural consequence of how space-time is organized. Light traces the skeleton of reality, and causality hangs from it like muscle and flesh. Everything that happens must follow those lines, and everything that cannot follow them is simply never allowed to happen at all. The idea that motion becomes relative while light does not is one of those facts that sounds almost trivial until you follow it far enough that it starts to feel unsettling. In everyday life, motion is negotiable. Sit in a chair and you are still. Ride in a car and you are moving. Fly on a plane and you are moving faster still. None of these descriptions is trivial. Jed. Each makes sense from its own point of view, and physics happily agrees with all of them. Speed in this familiar world depends on who is doing the measuring. Light refuses to cooperate with this flexibility. No matter how fast you move toward it or away from it, no matter how cleverly you arrange your experiment, light always clocks in at the same speed. This is not because our instruments are clumsy or because light is hiding something, but because the universe is built to make this true. Motion must adapt. Light will not. The result is that velocity loses its absolute meaning while light speed gains it. Once you accept this, the dominoes start to fall. If two observers are moving relative to one another and both measure the same speed of light, then something else has to give. The universe chooses space and time. Lengths shrink along the direction of motion, and clocks tick more slowly for moving observers. These are not optical illusions or measurement errors. They are physical changes required to preserve the stubborn constancy of light. Motion remains relative, but the cost of that relativity is that space and time themselves become elastic. This elasticity is deeply counterintuitive because we experience space and time as solid and dependable. A second feels like a second. A meter feels like a meter. But these experiences are local agreements, not universal truth. Move fast enough, and those agreements dissolve. Two observers can measure different lengths for the same object and different durations for the same process, yet both be correct. The only thing they will always agree on is how fast light moves. What is striking is that this does not introduce chaos. On the contrary, it introduces a deeper consistency. The laws of physics take the same form for all observers precisely because light speed is invariant. Motion can be traded for distorted space and time, but the underlying rules remain intact. In this sense, light acts as the anchor that keeps physics from drifting apart as perspectives change. This perspective also reshapes how we think about rest. There is no universal state of being still. You can always find another observer for whom you are moving. But there is a universal standard for light. It does not rest, and it does not slow down. It occupies a special status, not as a substance, but as a boundary. Massive objects are forever confined to speeds below it, while massless ones are compelled to move exactly at it. Light marks the divide between what can have a rest frame and what cannot. Even more intriguing is how this plays out in extreme situations. As objects accelerate closer to light speed, the energy required to push them further increases dramatically. It is not just hard to reach light speed, it is forbidden. The universe resists the attempt by warping time and space more and more severely. Motion remains relative all the way up, but light speed stands firm, unreachable, and unchanged. This leads to a quiet but profound conclusion. The relativity of motion is not a weakness in our descriptions of nature. It is a feature enabled by a deeper invariance. By holding light speed fixed, the universe grants motion its freedom while preserving order. Everything else bends so that light does not have to. Once you see this, the world looks slightly different. You stop asking how fast something is in an absolute sense and start asking relative to whom. And hovering above all those shifting viewpoints is the unwavering pace of light, silently defining the limits of motion and reminding us that not everything in the universe is up for negotiation. The notion that information in the universe has a strict limit feels almost insulting at first, especially to a species that prides itself on curiosity and reach. We like to imagine that with enough ingenuity, enough machines, and enough patience, any fact can be uncovered and any message delivered. But the universe is less permissive than that. It allows information to move, but only under carefully enforced rules, and those rules are written in the language of light. Information is not an abstract ghost that floats freely. It must be carried by something physical, a photon, a particle, a vibration in a field. The moment information becomes physical, it inherits the constraints of the universe, and the most important of those constraints is that nothing carrying information can outrun light. This turns light speed into a governor on knowledge itself. You may want to know what is happening far away, but you can only know it once the information has had time to arrive. This delay is not a technical inconvenience, it is a fundamental feature. When you look at the sun, you see it as it was minutes ago. When you observe distant galaxies, you see them as they were billions of years in the past. Even your awareness of the room you are in is stitched together from signals that took a finite, if tiny, amount of time to reach your senses. The present you experience is always slightly out of date, a carefully curated archive assembled at light speed. The limit on information also explains why certain regions of the universe are effectively sealed off. Beyond the observable horizon, space is expanding so rapidly that light from those regions will never reach us. No future technology can fix this. No clever detour exists. Information from those places is not hidden. It is causally inaccessible. The universe contains more than we can ever observe, and it does so unapologetically. This has consequences for how we think about prediction and control. You cannot react instantly to distant events, no matter how urgent they are. By the time information reaches you, the causal moment to intervene may already be gone. This is why the universe feels stable rather than twitchy. Local actions have local consequences first, and global consequences only later, if at all. The speed limit on information prevents reality from collapsing into a frantic, instantaneous feedback loop. There is also a subtle generosity in this constraint. Because information cannot travel infinitely fast, systems can have privacy. Black holes hide their interiors behind horizons. Quantum systems limit how much information can be extracted without disturbance. Even everyday objects carry more microscopic detail than can ever be fully known. The universe is not obliged to reveal itself completely, and the limit on information ensures that it never does. At the same time, this limit gives information real value. A bit of data is not trivial if it had to traverse vast distances or survive extreme conditions to reach you. Every observation is a physical achievement, paid for in time and energy. Knowledge is not just collected, it is earned by respecting the constraints of space-time. Perhaps the most unsettling implication is that no observer can ever possess a complete picture of the universe. Different observers have access to different slices of reality, depending on where they are and when they are there. The universe has no master vantage point where all information is available at once. It is fragmented by design, parceled out according to light's finite pace. So the strict limit on information is not an obstacle to understanding. It is part of the universe's architecture. It keeps reality coherent, prevents paradoxes, and gives meaning to observation itself. The universe speaks, but it never shouts, and it never speaks faster than light allows. The idea that what we can know is shaped by how light travels forces a quiet reevaluation of what knowledge itself means. We often treat knowledge as something limited only by intelligence or effort, as if the universe were an open book waiting patiently to be read. But light does not move instantly, and that single fact places boundaries around every possible act of knowing. The universe does not present itself all at once. It reveals itself piece by piece, at a pace set by light and never faster. Every observation is an encounter delayed by distance. When you look at anything beyond your immediate surroundings, you are not seeing it as it is, but as it was when light last departed from it. The farther away the object, the older the information. This means that knowledge is always historical. Even the night sky is not a snapshot of the present universe, but a layered archive with nearby stars reporting recent news and distant galaxies whispering ancient stories. Light turns space into time, and knowledge into archaeology. This delay is not just a cosmic curiosity, it defines what questions can even make sense. You cannot ask what is happening right now on the other side of the galaxy in any operational way, because right now has no shared meaning across such distances. Light refuses to synchronize the universe for us. Instead, it enforces local perspectives. Each observer carries their own window of access, bounded by how far light has had time to travel to them. There are also absolute limits, beyond which knowledge is not merely difficult but impossible. Event horizons form where light itself cannot escape, sealing off regions of space-time permanently. What happens beyond those boundaries is not unknowable because we lack cleverness, but because the universe has removed the causal pathways required for knowledge to form. No experiment, no probe, no future civilization can retrieve information that light cannot carry out. Reality, in these cases, exceeds what can ever be known about it. This has a profound implication. The universe is larger than its descriptions. Physical theories, observations, and models are always partial, not because they are flawed, but because access itself is limited. The universe does not owe us completeness. It allows understanding within the corridors carved out by light, and beyond that, it remains silent. Knowledge is not a mirror of reality.